Hey guys, today we are going to take a look at the equation of a line in what we call standard form. Alright, so first of all, what is the standard form of an equation of a line? Well, I've already written it in here, so you didn't have to watch me write it this time. A linear equation with all terms on one side of the equation and whole number coefficients. So in other words, it's going to look like this guy over here. Okay? It's going to look like that. You see, we still have our x, we still have our y, but they're on the same side of the equation. We also still have a constant term, okay, right here. But again, it's on the same side of the equation, right here. All right. So the other thing you'll notice is we've got an a, a b. I don't know why this looks all weird, but whatever. We've got those three letters there. Those will all be numbers, okay? All three of those will be numbers. None of them should be fractions either. Okay, standard form is probably the best looking version of an equation, or the equation of a line anyway, because we only have whole numbers, everything's together, it looks very pretty, and it'll always equal 0. All right, that's what makes it standard form. Now, here's the thing about standard form. It's not particularly useful. Now, we'll learn in future lessons other ways to deal with it, but the easiest way to deal with the standard form of an of a line is to convert it to slope y-intercept, okay? Because we're experts at dealing with slope y-intercept. We're experts at dealing with this y equals mx plus b. So we're just going to change it so that it looks like that, all right? So for instance, number a here, we've got 2x plus y minus 4. So what we're going to do is we're going to look and we're going to say, well, this 2x, I'm going to pick a smaller line here. Let's go. Oh, this isn't working. There we go. All right. So we've got this 2x here, and we've got this minus 4 here. And they are on the left. And if you look at your slope y-intercept, of course, they are not on the left. They're on the right. All right, so what we're going to do is we're going to move them over, okay? And we're going to be left with y equals, let me switch back, y equals, the y stays where it is, we didn't move it. So now we're going to have our 2x and our 4. But of course, when we move them over, they changed signs. So it becomes negative 2x and plus 4, okay? And that's it. That's all there is to it, all right? And from here, we can, of course, graph it and do all the things that we're used to doing, okay? So for this question, it asked us to state the slope and the y-intercept. Well, now that it's in slope y-intercept form, it's easy to say, well, the slope is just the negative 2, right there, and the y-intercept, or the b value, is 4, all right? So there we go. So that was probably the easiest of these types. This one is slightly harder, all right? Once again, we have to move our x over, we have to move our 6 over, okay? The y stays where it is, but you'll notice that it's a 2y, so even though we move everything else over, we still have a 2y. So over here we're left with negative x, we're left with plus 6. Okay, but we're not done because we've got that 2 in the way. So what we're going to have to do is we're going to have to get rid of it. And to do that, we will just divide everything by 2. All right. Make sure you divide all three terms by the 2. Don't miss, often we miss the y-intercept. So the y is all that's left over, and if it's not just a y that's left over, it means you've done something wrong, because the only reason we divided by 2 was to make it so that the y was by itself. Okay, with the x, we've got negative x over 2, but we're going to write that as negative 1 over 2x, which is exactly the same thing. But this way we've got it written as a slope. We've got the slope written as a fraction so that it will be nice and easy to graph if we need to do that. And of course, 6 divided by 2 is just 3. So I'm left with a slope of negative 1/2, and I'm left with a y-intercept of 3. All right? So let's look at an even slightly harder one. Once again, we got to move the x term and the constant term to the other side. So we're left with negative 3, oh my goodness, negative 3y. Don't forget that that negative 3 there is connected to the y. You can't just remove that. That will stay with the y. We can't move that to the other side. We're left with negative xy, or sorry, negative x now, or negative 9x I mean, and we now have a negative 18. Okay? So we're going to do the same thing. The only difference here is that that y value, the coefficient on the y value is negative, and that doesn't make a difference. We're just going to divide by a negative 3. So whatever value you have in front of the y there, you're just going to divide by. And so that will leave us just with y equals negative 9 divided by negative 3 is positive 3, so we're left with 3x. Negative 18 divided by negative 3 is equal to positive 6. And there we go. So we got a slope of 3. We have a y-intercept of 6, and that's it. That's all you have to do. All right? Okay, so let's just quickly go over the steps here. So our step 1, okay, step 1 was we're going to move, we'll call it the x term and the constant term. Constant term meaning the term that does not have any variable attached to it. Whoops. Term to the right side of the equation. So that's our first step. And then our second step was we divide all terms by the coefficient of the y term. Okay, and that's it. All right, now I've called them x and y. In this next example, we'll be using different variables, but it works the same. Remember, when we say a y term, we're talking about the dependent variable. When we say the x term, we're talking about the independent variable. All right? Oftentimes in application questions, like we're going to see, you're going to have an independent variable that's going to be a lowercase and a dependent variable that's going to be uppercase. That's not always the case, but it is a frequent thing that you will notice. All right? So this next one, we've got a banquet hall, and it uses this equation here to determine the cost of the hall. C is the cost, and N is the number of people that are attending. So the first thing we're going to do is we're going to express this in slope y-intercept form. So first let's just copy out the equation. Often the biggest, or I should say most common mistake, the easiest mistake to make is that we don't always copy the question down right, and then it's hard to get the right answer when you've got the wrong question. So do be careful when you're copying out your equation. Make sure you get it right. All right? So first of all, we have to decide which variable is it that we're isolating. So you want to isolate the dependent variable, the variable that you want to determine based on the other variable. So in this case, it's going to be the cost. We want to figure out what the cost is. All right? So we're going to move our 50N, and we're going to move our 1,000 to the other side. All right, so we'll be left with negative C is equal to negative 50N, remember to change it to a negative, minus 1,000. All right, now we just have to divide by whatever the coefficient is, and of course the coefficient is kind of invisible here, but it is there. Remember, it's a negative 1 in this case. So we're going to divide them all by negative 1, works out quite nicely. We'll get C equals 50N plus 1,000. All right, and that's our equation. So the next question here is to identify the fixed and variable cost. right, so these are terms we've only briefly mentioned, but your fixed cost is going to be the cost that you have to pay no matter what. All right, it's fixed. It doesn't matter how many people are going to your banquet, you have to pay that money. All right, so in this case, it's going to be this 1,000 because it's not touching a variable. Nothing affects it. It's always just 1,000. All right, so our fixed is going to be $1,000. Okay, our variable cost is the one that's going to change depending on the independent variable. In this case, every time a person comes to our banquet, we have to pay an additional $50. All right, so our variable cost is going to be $50 per person. Okay. So we're going to graph it. So now that we have it in y-intercept form, or slope y-intercept form, this is a lot easier than it would have been if we were trying to do it from standard form. So we want to start with our y-intercept, which is going to be that fixed value, that 1,000. So that's our y-intercept. So we're going to put a dot right there. And now we're just going to use our slope to figure out what comes next. Okay, so we've got a slope of 50. Okay, now that can be a little challenging in a question like this because if you look at our scale, we're not going over by 1, so we want to go up 50 over 1. It's going to be pretty hard to go over 1. So I'm actually going to go over by 10. Because if you look here, each of these boxes is 10. We got 10, 20, 30, 40, and 50. So I'm going to go up, so we're going to go over by 10, which means I need to go up by 10 times what I would have gone up. So instead of going up by 50, I'm going to go up by 500. All right? So, as luck would have it, these boxes on the side are 500s. All right, so we're going to go up 500 over 1, which brings us here. Okay, up 500 over 1, and you can see that this is the pattern. Now, you can check this by plugging 50 into your equation, okay, and it is right. Okay, so now we just need to draw a line. So again, this is always a challenge on my tablet. I got to use a ruler that doesn't detect my fingers through it. So let's go. This isn't working well at all this time. There we go. Well, that's good enough. All right. I don't know why it's all fuzzy. There we go. All right, so there we go. So there's our line. All right. Now we do have to put our titles here. So this is going to be number of people. Okay. This is going to be total cost. Right. Which is going to be measured in dollars. Okay, our graph we can call, I don't know, let's call it cost of banquet hall. Okay, and finally, we're going to label our line, which we will label it with either version of our equation. I personally like to label it with what was given, okay, but that's not an actual rule. Okay, so I like to put 50n minus c plus 100, 100, or no, 1,000 equals 0. All right, but you could easily use the version that we found, the c equals 50n plus 1,000. Doesn't make a difference. All right, there we go. So what is the rental cost if 1,000 people attend? Well, if 1,000 people attend, we could use our graph, but our graph only goes to 200, so we're going to use the equation. All right, it'll be a lot easier. So we'll have c equals 50n plus 1,000. Oh, actually it says 100, doesn't it? I can't read. All right, well, I'm still going to use the equation. All right, so we just replace the number of people with 100. Okay, so we get 5,000 plus 1,000. So it'll cost $6,000. All right. So therefore, it would cost $6,000. All right, and we can double check that with our graph here. In fact, this is probably how we were supposed to do it. We just go up and we say, well, it crosses right there. And look at that, it's $6,000. All right. How many people can you invite if your budget is $2,800? Now that's going to be a lot harder using the graph. So we're going to use the equation for this one for sure. Now you could actually use either version of the equation. So yeah, if you want, use the standard version. You know what, let's use the standard version just for fun. All right, so I'm just trying to be able to see it there. Well, unfortunately I wrote it on the graph. So I'm going to write it out as 50n minus c plus 1,000 equals 0. So I'm going to use this version. All right. Now, the $2,800 is going to go in for C because that is the cost. All right. So we'll say 50n minus $2,800 plus 1,000 equals 0. So I can collect some like terms here. I can have 50n minus $1,800 equals 0. So 50n equals, we move the 1,800 over, it becomes positive 1,800, or 1,800. Okay, I divide both sides by 50. And we get n equals 36. All right, so therefore, we could invite 36 people. And that is it. So, sorry this one was a little long, but until next time, go Sabres.